All right, this is a video for the Unit 4 Part 1 packet, practice number 1. We're going to do number 1 and number 2 in Part 1 practice. Number 1 is very similar to number 3 in the notes. Okay, so it says a ball is thrown upward into the air. So let's draw a picture. Here you are. You have a ball, and it is thrown up into the air before it comes back down. We'll even put the ground here. Right? So you throw a ball into the air. Its height is modeled by an equation. Well, just like the last problem, notice that the path of this ball is upside down, the parabolic shape, which means, remember, an upside down parabola has a negative leading coefficient, which would look like it's only C and B, or D and B, I'm sorry. A and C would be graphed like this, up, opening up, which isn't the way you throw a ball. So cross A and C off. We need to figure out now the only difference is looking at it still plus 5t in the middle, these constants at the end, positive 15 and negative. Well, remember, those two numbers on the end of your equation represent the y-intercept, which in modeling is called your starting value. And it makes more sense to start throwing something from a height of positive 15 than to throw it from a height of negative. That means you would be throwing it from underground. So that means that B is going to be the equation you would use. All right, that's number 1. So we'll do number 2, and that'll be it for the video. It says bacteria tend to grow very fast in a petri dish at first because of unlimited food. All right, so you put bacterial spores on a petri dish, which is a medium for growing bacteria. They grow really fast because there's food to eat, and then eventually when they eat all the food, they start to die. So the number of bacteria is modeled by this equation. This T is the number of hours since you start, and N is the number of bacteria. So it says, at what time will the bacteria reach the maximum? Remember, this lesson, part 1, is all algebraic. So we're going to use this formula to find the maximum amount. Okay, now, it says what time. And when we find a vertex using this, our vertex is always an ordered pair. So this formula finds us the x value of the vertex, which here is representing the time, which answers the question, at what time? So instead of x, I'm going to use t equals the opposite of b over 2a. We're going to take the opposite of b. B here is 92, so we'll do negative 92 over 2 times a, which is negative 2. So that's negative 92 divided by negative 4, and we can simplify that in Desmos to be negative 92 divided by negative 4, and that gives you 23. Positive 23, and the unit here is 23, we said hours is time. So it takes 23 hours, and after 23 hours, there are the most bacteria that there's going to be. Now it says figure out at 23 hours how many bacteria is the maximum number. Well, if I know that the x value of my vertex is 23, to find the y value, I have to plug 23 back into the equation. So I'm going to find the number of bacteria after 23 hours by using the equation. So what this looks like is you'll take negative 2 times 23 squared plus 92 times 23 plus 625. And you're going to carefully type that expression into Desmos. All right, so negative 2 times 23, close your parentheses to square, plus 92 times 23 plus 625. And you get that the number of bacteria, that is right, it's 1,683. So that's the most bacteria, and you need to include units, that are going to be on this petri dish. So it takes 23 hours, you get up to 1,683 bacteria, and then they start to die. So it says how many bacteria were initially introduced to the Petri dish. Well, if you have an initial value, there's two ways to do this. That's the starting amount or the y-intercept. So one way to do this is to put time 0 in, because that's what your time is when you initially start. So you would take your equation, number of bacteria at 0 hours is -2 times 0 squared plus 92 times 0 plus 625. So if I go back to Desmos, let me just change these values to be 0, and you get an answer of 625. So that is the number of bacteria that you start with. Now the second way to do this problem is to remember what we talked about in the notes in the last column. The constant on the end of standard form is the y-intercept, which is also called your starting value. So that 625 is how many bacteria you start with, and you could read the sentence here. It says you start with 625 bacteria. All right, finally, how many bacteria will there be after 1 day? 1 day is 24 hours. We're using hours here in the problem, so we should use 24 as my time. This is going to be similar to part B. We're going to find the number of bacteria after 24 hours. So we're just going to put 24 in 14. And you're going to type that right in to Desmos. Again, just like the last two problems. So instead of 0, I'm going to change those to be 24s. And it tells you that there's 1,681 bacteria after a day. And if you are not sure why the number went down, remember after 23 hours, this was at your maximum. So that 1,683 is the most bacteria you have, then you start decreasing, and an hour later you have 1,621 bacteria. Alrighty, so go ahead and try number 3 on your own. If you need extra help, check the key on Canvas or ask your teacher for help.